all, it'll start showing you some errors.
All right. Oh, I have to look at that.
You may also need to check and see what version it's using. I think it was pointed out that I think this was created in Python 2. Probably should be Python 3. You can find that under the Edit tab, I believe. There it is. All good.
I see. Okay.
Yeah, so what's the first error? This one was, well, there's two train X's there on your regular fit.
Mm-hmm.
You got to have a train X and then a train Y.
That makes sense.
Okay. My understanding is that's pretty much the first part. Now you move to section 2.
Okay.
And if that runs, I just kept moving on.
Okay.
You wanna change the predict to test.
The predict to test.
Yeah.
That's what I thought too, but I went through the whole coding challenge and then they said do it again for test. So I think, and the instructions above say using the test set instead of the train set after you've done it. So I think we can leave that now. And
I think we're supposed to use the train set on the first round and then you repeat at the bottom.
Okay.
Yeah, the title on the above the block was not right. Yeah, it should be train here.
Yeah. There were a lot of errors.
Not the train set. That train set. Okay. Cool. And so then we observe precision, which one? Oh, because we have to.
You have a double equals there on the false positives.
Which we don't want.
Below that. So it's double equals instead of a single equal.
I see. Okay.
I think. I mean, if somebody has a better idea, let me know.
Yeah, we want to change that minus into a plus for y hat minus train y.
All right. This is all excellent. What is the, okay. Can someone explain in English what is occurring in this?
I'm not sure if we should change it to plus. It should be minus only.
And your argument is?
False positive is when the predicted is positive and the actual was not positive.
Okay.
And yeah.
Okay, so it doesn't make a difference then in that case.
Why?
Because if the true, okay, so if it's a false positive, that means that y hat would be 1 and train y would be 0.
Yes.
Right. So regardless if we add or subtract train y.
True. But I think the correct definition is minus, because if the values would be something different, then it might matter. Yeah, right. Because if it would not be Boolean, then it might matter. I think the definition of the false positive above the comment in the comment is also wrong. That's the definition of, I think, something as probably a true negative. Because false positive is if the prediction is 1 and the original data is 0, their subtraction should be 1. If their sum is 1, then even a false negative would also be the sum would also be 1.
Right.
False negative is when the train is positive and the y hat is 0. So that would also be 1. So the comment above is not super accurate. It would be correct, but it's not super accurate.
Because it also would be true for the case of a
yes. So it should be their subtraction is 1 in the comment above.
I think I agree with that. Anyone want to argue? Take that as a no. Okay. Oh, interesting. Well, okay.
Behnam,
Yeah.
I think you want to check the data, the original data,
Mm-hmm.
like the way it was imported, because just make a new cell.
Okay. Below where we're working right now?
No, above it, above it. Yeah, like right there. Doesn't matter. Print the first head of the data set.
What's the name of our data? Data. Is it a dot? I don't remember if it's a dot.
So it's with the parentheses. So the first column should be the index.
Mm-hmm.
Change it.
Okay, so we need to just get rid of the first column.
Yeah. So go to where you're next to the URL and just correct comma. Index col equals 0. Yeah.
All right. Is it an underscore? Well, we'll find out.
There you go.
Excellent. Okay. Okay. And so our output for when we're observing the precision, I'm assuming this gives us the index of the training value, or I guess like, so it's like the 11th data point. Okay, well, anyone have an interpretation for the output here?
Yeah, it's all shuffled because of when we did train test split, and then it's going to be false if that particular thing, the prediction and the actual value sum to 2.
Okay, okay. So in this case, then we would interpret saying like the 11th data point, I guess, is not of the one of, it's not a true positive, but one of the other 4, or other, yeah.
Yeah.
Okay. Okay. So that means we predict true and get true. Not that often. Okay. We predict true and get false once. Yeah. Okay. So assuming, do we not want to also look at true negatives and false negatives? Yeah. Or does that come later in the code?
I think it might not be needed in the true positive rate and the false positive rate, because their definitions are just false positives divided by something and true positives divided by something. That's why maybe.
Okay. Is that, where, do you have the specific definition for that?
I think it's in the, it was in the wiki, yeah, one of the wikis.
Okay. Oh, are you referring to like the precision and recall definitions?
I know the true positive rate and false positive rate.
Well, okay. Well, that's fun. Okay. I'm not going to delve into that right now. But I guess assuming we don't need to compute explicitly the false positive or the true negatives or false negatives, I guess we can just check out the next code cell. Okay, and so these are just the, I guess, like probabilities associated with each prediction. Okay. Okay, so now we actually do something interesting. And we have a syntax error. Okay. Hey. Okay, I will now crowdsource for any interpretations of this table. Okay, fine. I'll put mine out first, and then you can tell me why I'm wrong. So it looks like for each data point, we have, it says a decision threshold, I guess. Okay, we'll come back to that in a second. Don't want to get too scattered.
Right, so you'll notice for like each data point, there will always be ones on the left, and at some point they stop and they turn into zeros as you move to the right. So we can then just interpret like each entry as, you know, is this particular data point given a probability of more than whatever the threshold is. So data point 0 is, you know, more than 0.4 of a chance of being, I think, like 1 or something, right? I could be wrong. I'm not sure what the probability is, but
yeah. That makes sense to me, I guess. So then we would interpret that any for any data point whose threshold is beyond 0.5, the predicted value then is going to be a 1.
Yeah, that's what I would assume. Yeah.
Okay, so this is just like a visualization of the prediction paired with the probability associated with that prediction.
Yeah, I'm not sure like this is meant for like human eyes. I think it's more useful for like graphing, because we could just put a 0.5, like we could just look at the probabilities, right?
Right. Okay, so then do we attempt to make a graph out of this?
Yeah, we use probability below to make a graph.
Okay, let's find out. Okay. Aha. Okay. Oh, there's a graph. So, okay. All I'm understanding about this so far is that there's a threshold that we can modify that will change the relative rate of false positives to true positives. But in the context of logistic regression, I'm not sure what specifically, are we changing like the model parameters itself or something like meta after we've already trained our logistic regression model? Discuss.
I don't think we are changing anything, Viman. It's probably just a visualization of how the model had performed. Unless you go back and rerun the logistic regression on, some different parameters.
Okay. False positives based on the sliding decision threshold. Okay, so that's, I think maybe that's where I'm in the dark.
The threshold is just, I don't think the threshold is just a range of, values where we want to kind of see the curve.
Okay. Positive rate.
So you remember, like in the above code blocks, once we did, our regression model had a method for predict, and that gave us a bunch of ones and zeros, but then it also had like a predict proba, and that gave us like real numbers. And so the predict by default would set the decision threshold to 0.5. And so here we're just
Okay.
we're just using arbitrary ones, because you can see that predictions is actually that array that we made in the last code block. So yeah.
Oh, okay. I understand that. That makes sense. So the curve itself is fixed, but where along the curve we decide to switch from predicting 0 to predicting 1 is changed by what we choose to be the decision threshold. Does that sound right?
I think so.
Okay. Okay. So, that makes sense to me. But then the question is, does this graph show anything to do with the decision threshold? I don't think it does.
No, we don't directly plot that, which makes it, more confusing.
Okay.
So that graph just shows you how accurate your predictor is. So if it was, if the blue line was closer to what the dotted line is, it means that your predictor is not very good. I mean, if it was like almost a flat line, it will be like just like a random guess, where this is showing you that it is pretty accurate.
Oh, I see. Okay, because it's saying basically that you're able to, with this model, improve your true positive rate up to like, that looks like sort of like 0.85, while only allowing a false positive rate of like 0.05 or 0.08 or something, which is not bad. In other words, you don't suffer too many false positives for a certain degree of improving your true positive rate. But then the more you try and improve your positive rate, you'll get these spikes in the false positive rate as well. That's my interpretation of this graph.
Right, yeah. And then to relate that to the decision threshold, the origin of that graph corresponds to a decision threshold of 1, which means that like no matter what you have, like you're just going to always predict it's negative, which means you'll get no false positive, but also no true positives. And then over at x equals 1, that would be a decision threshold of 0, which means that everything you're predicting is just positive, which means you'll catch all the true positives, but also all the things that are supposed to be negative, you'll also assign as positive. And then everything is something in between.
Okay, and so does that mean, can I extrapolate then that moving up along the line well, no, that doesn't make sense.
No, I don't think we can say much about the relationship in between.
Okay. So this is the same plot idea conceptually, but we're using a different metric. Producing the same false positive data via a library and plotting it. Okay. So not that different at all. We just have a difference in this
I
little.
think the number of points are different. That's probably it.
Oh, okay. Two, compare using the test. Do you want to try and hammer this out? Hell yeah. I mean, heck yeah. Okay. So this means do we just apply the exact same thing, but just swap out test set, or do we want to?
I made a copy of the entire thing and did the whole worksheet and using the test set.
Okay.
I'm not sure I'm not sure you have to do all that, but with no better understanding than I had at the time, that's what I did.
I did the same thing.
That makes sense. So long as we're not retraining the model and instead just, you mean from like 3 on?
Probably you need two also.
2 as well. Okay.
I made a new copy of the worksheet and in every code block changed train to test.
Okay. I think I agree with that, except for the case when we train the model initially. We want to, I think, still train the model on the training data, right? Once we have that, though, then all further analysis we would want to do on the test set. So we already have our predictor. Yes. Thank you, Charlie.
That you need to copy over is the proba equals regression dot predict proba.
Yeah.
That's the only real line that you need to copy. If
Okay.
otherwise, you'll need to.
We're just going to do this the long way.
Oh, and then you also need to copy where they use the library in the code block just above.
Okay.
I think you need the y hat also, right? The second block, because the y hat was calculated for the train x. Even above.
Even above this?
Yeah, but you don't actually use y hat when you get the ROC, because that's assuming a arbitrary like 0.5 decision boundary.
Yeah, it's true. They don't use the y hat below.
So in this case, we'll want to swap out for test y, right?
Yeah, if you want to see this comparison between the two true positives and false positives, then you would need the y hat,
Okay.
like for the test set. I think Raymond was saying that we don't use it for the library. I mean, we don't use it for the plotting.
Yeah, that's correct. For this, you'll need the y hat.
Oh, I do need the white hat? A different
Yeah, you
white
do
hat?
need. No, yeah, different for the which you run on the test set, which you predict on the not the train set but the test set.
Okay, I see. Okay, let's see what's happening here. So we have a really small test set. Okay.
Now you probably want to change that variable. Yeah.
Nice. Dope. Okay. And that seems to be behaving. Okay, so we have all that. Does anyone have an interpretation of this? The decision function computed by logistic regression before the loaded function has been applied? Is this just giving like a a linearized, I guess, prediction function?
Yeah, I mean, my interpretation was it's probably before that, the squashing function, like the logit function, um, uh, like the sigmoid. So it probably could have coefficients which is greater than 1, and then it kind of gets squashed down between 0 and 1. I'm not sure though.
Okay. So this is...
Yeah, so it's like the form of the sigmoid is like 1 over 1 plus the exponential of like some parameters times the data.
Mhm.
So like that's just the parameters times the data before they've been like placed into that exponent.
Okay.
Because the logistic expression kind of derives itself from the linear regression. So probably would be doing this as the last step where it puts the coefficients or the input into a sigmoid, and this is just before the sigmoid.
Okay, so there is no expectation on our part that we could reasonably interpret this, these numbers in a meaningful way.
It is the distance between the hyperplane and yeah, it's the distance between the hyperplane and the sample, I guess, and the sample to that hyperplane.
Okay, and so this is like in an untransformed space where...
That's what it tells in the SQLN documentations. It's a confidence score, so that's a kind of score. That's what I guess. Yeah.
Okay, I'm not quite sure I understand that, but maybe someone else did. Okay, cool. Let's see if we can finish this off. Compute and sort, which is not what we've done yet here. We did this part. Okay, new variable time. Well, this is fine. Problem. Oh, shoot. Does anyone see anything else that ought to be changed in this block of code beyond what I've just changed here?
Yeah. The probability of your test set, I think. Yeah, you change the probability. Yeah, that thing is correct.
Okay. And so everything else is defined within the form?
Yeah, that's correct. Yeah.
Okay. We'll just leave that there. I hope that's fine. And then, okay, now we can make pretty graphs. False positives. Test.
I think you don't have to change that thing, I guess. You just need to change the train y values to test, and you can just copy paste same thing, I guess, in the separate code block.
I agree. I just don't want to
Okay.
overload my variables twice. Like, I think that this would end up defining what we've done earlier, and then if we run everything, we can't see the difference.
Okay.
Test y. No, but we've...
You want to change your print statements to print the
Yeah.
right things too.
The previous code block.
This one? Ah. Or
No, the one you, yeah, this
down
one.
here.
Yeah.
Okay.
Yeah, there.
NP.sum. And in a for loop as well.
And predictions, which I just decided to rename up here because I'm making a mess. Predictions. No, I'm not going to touch that. That's fine. Huh. That looks suspiciously good.
Yeah.
I probably goofed somewhere.
I don't think so. I tried many combinations and I was always ending up with the same curve.
Okay. That makes me feel better then. Positive rate at a threshold of 0. So we're looking at our test data right now with the model that we've already created on our training set. And what this is telling us is what? So the false positive why is this so much better than what we got with our training data?
I think just a smaller sample size. I mean, maybe try increasing the sample size. I'm not sure.
So this is less indicative of how good our model is as opposed to just how little data we have to test it on?
Probably it's just like 10 samples.
Yeah, okay. Statistically insignificant, no, okay. All right, I hope this has been to some extent helpful for you guys. I wasn't exactly planning on doing this, but does anyone have any questions that maybe someone else in the class can answer for you?
We should probably try with a larger test set and see if it's, I mean, just reverse the percentage to like, instead of 0.2 to like 0.8 or something.
So this is in our initial partitioning of the data?
Yeah. The graph does look very suspiciously, very too accurate.
Yeah. Train test split. Is there an argument we can feed you?
Test size.
Test underscore size?
Yeah.
Equals, so right now is it default to 0.2?
Yeah, or 0.3 or something.
Or else like you can take like the entire data set and you can predict it instead of splitting it into like 2 train and test. So data will be like a very large data set, right? So.
Okay, I'll try something like this maybe.
Yeah, it's even go bigger, you can go probably like 0.5.
0.15?
Yeah, 0.5. Just divide it into 2. Let's see what happens.
Half and half. All right. Don't break. Making sounds. Wow. Huh. Okay, so that is our training. Okay, yeah, I'm happy with that. That seems realistic. Cool. I have nothing else to offer. I think that's as far as I can take us anywhere interesting. Any word on Thomson's work? We currently have no information on where Thomson is, but hopefully he will show up soon. Share collab when you're done, please. Ah, yes. Let me see if I can do this right this time. Oh, wait. Okay. Where is the random seed and the test size? Okay, that's a good question. My hunch is that the train test split.
They have the default value, Troy.
Yeah.
Function just takes whatever the default value is. I think it's 0.33 and 42.
Okay.
It's in the documentation of scikit-learn.
I was pretty sure there was some sort of a default because the code worked, but
All right, cool. Yeah, we'll see if we can find you an instructor in the next 10 to 15 minutes.